and it's really an honor and a pleasure to be here. My name is Ariel Cintron Arias. So there are two co-hosts of this workshop here. I'm going to introduce myself and then I'll let Andrew to do his introduction. I work as a professor in the Department of Mathematics and Statistics of East Tennessee State University. My formal training is in computational applied mathematics. And when I was young, so almost 2 decades ago, my formal training was in using mathematics for better understanding infectious diseases. And perhaps in the middle of the pandemic was when I tried to kind of skill myself towards these methods we're going to be talking today about artificial intelligence, machine learning, and to some extent cloud computing. So today's workshop is something where we're going to discuss a few things on the screen. At times, we're going to have an activity. You will be able to use your browser and we'll take a few minutes for you to kind of use your browser in a certain manner and then maybe chime in either in the chat as you're doing already. And in some cases, if you'd like to answer or ask a question, you're also welcome to do that with the microphone as well. So, Andrew, please, this is your chance.
All right, good afternoon, everybody. My name is Andrew Holt. I'm currently a graduate student right now at ETSU, or East Tennessee State University, working towards a job embedded graduate certificate. So pretty much what that is instead of doing the traditional teacher education of doing a second semester of student teaching, I've actually graduated early with a bachelor's degree to go ahead and teach in the classroom while I'm finishing up my education program. So right now I'm currently working at Unaka High School, which is in Elizabethton, Tennessee. And this is my first semester as a math teacher, and I'm also a baseball coach. And I was fortunate enough in college to have Dr. Cintron as one of my math professors, and I guess that I've learned a lot about artificial intelligence with him, and he's been a great mentor to me, and I appreciate him from that. And we've got a great workshop planned for you today.
Excellent, very generous words from Andrew. So we'll see if our workshop meets the expectations that Andrew just set up here. So I'm gonna start by sharing my screen. I have two screens, and one is on my left. So sometimes I'll be looking. It's not that I'm distracted. I also have my dog here sitting on the right side of me. So hopefully there will not be a concert, but here we go. So when talking about artificial intelligence, um, we're going to engage in an activity in just one or 2 minutes. So I'm gonna start by making this statement, and then you're gonna play with something that Google has easily accessible, and then we will circle back about defining artificial intelligence. It's not like in mathematics there are so many terms where you have a very unique and precise definition, continuity of a function, or even a function itself, or a theorem, or something like that. For artificial intelligence, there is some agreement and some disagreement as to how do you actually define that. And what you see here stated is that more or less is this exercise or this task of making computers perform certain tasks in a way that resembles how humans would do those tasks. So typically, this involves about tasks that involve making decisions or solving problems or making predictions. That's more or less, but it's not exactly like a universal definition that it's like this is the definition, and then that's the end of the road. So we're gonna I'm gonna demo this for you, and then I will paste the URL in the chat window. So for doing this demo, I have to get out of that slide mode. And this would be something that you don't really need to draw very precisely. I'm actually using a laptop that has a pad. You could use a computer with a mouse. Hopefully you won't hear the sound. When you play this on your end, there will be some sound if you have the speakers on. The sound is not entirely necessary. This application is called Quick Draw. I guess it's, well, you'll see what it means. So you're challenged with drawing something on the screen. You see it before you start drawing it, and you have a limit, a time limit to meet the challenge. So this says something about drawing the moon. So since we're doing the demo here, um, I'm gonna do something that's, kind of close to what on purpose. I tried to do my best over there. So I'm gonna do another, this one should be easy, especially for a person like me that I don't draw very well. But I'm gonna do something completely different that has nothing to do with that. I'm gonna make on purpose some kind of mistake. Um, and you can see the computer is telling me, I'm playing this against the computer. The computer is guessing what I'm submitting here as a response to that challenge. Yeah, so then there will be six of such challenges that are presented to me, and each of them doesn't appear immediately. I have the ability to first read what they're asking for, and when I hit got it, is when I go into the mode of drawing, right? So I advise that you do your best if you want to play it, as best as you can. Fine if you want to make mistakes, kind of trying to trick the computer as I did there, my second attempt, that's totally fine. So at this time, I'm gonna switch. Oh, I'm gonna give you the URL. So let me clear this, and we're gonna take 3 minutes for you to play with this, and then we're gonna compare notes. So I'm gonna put this in the chat. There is the URL of Quick Draw in the chat, and I'm gonna set here a timer. And then I'm gonna mute myself and wait for you, and then we're gonna continue. We're gonna compare notes, perhaps chiming in what you observe on your end. Okay? Okay, so I trust that you were, you had the ability to explore what Quick Draw was doing. Let me switch back to this um, PowerPoint slide deck. And so maybe we can share now. There's a couple of questions here. Maybe maybe you can chime in about the second question. Compared to humans, what do you think of Quick Draw in terms of being better or worse at guessing your drawings?
I'll start this one out. I'll say that I think that it was better because if I, from my drawings, I'm not very good at drawing. So if I didn't know the word and I was looking at that drawing, I would have no idea what it was. So for one, it was wanting me to draw like lipstick, and it kind of looked like a pencil. So if I was looking at it without knowing the word, I'll have no idea what it is.
Yeah, I think it's definitely, I guess, how's this working? Yeah, so it could be this could be a function of the precision of the drawings. Also, you probably observed in the beginning, I on purpose was drawing the wrong thing, right? So if somebody is being much more efficient about the drawing something that's more approximate, then that would be more of a quality of the data that is being provided. But exactly. So Veronica is saying that some things he was very fast at guessing, and some other things was much more slower. Um, so and yeah, lots of things here. Okay, so let's see what we have in here. It's kind of a sample of different definitions. So I mentioned there is not really like a strong consensus about what is the definition of AI. Um, so perhaps you can take, I don't know, a glance of this at this, and maybe you can chime in the chat about what you see here is somehow some common factor, something that these definitions, what do you think they have in common? Right. So even though there is not a universal definition, um, these definitions, exactly, the people are chiming in, having the ability to do things like a human, training the technology to perform tasks. And so this is definitely bringing, I would say in my own words, that AI is a highly sophisticated form of automation. Now, the more traditional forms of automation, things that we would not think of as AI, are still technological. They're powered by technology, but they don't necessarily involve AI if they're based on rules. And the rules could be very simple, or the rules could be very elaborate and complex. But AI is a form of automation that goes a step higher in terms of sophistication, because it takes input data to then digest that input data and make decisions or predictions the common tasks that are performed by a human. So that's kind of on a nutshell um, what's motivated here. You see illustrations of three things on the left side of the screen. Something that has to do with image progression. This doesn't necessarily have to be powered by AI. In fact, you could think of back in the days before there was a way of digitizing photos of individuals that police departments would have an artist or several artists that would create portraits of people, and they could also do this thing about going backward in time and simulating going backwards, simulating going forward. So I see what Bering is chiming in. So there are forms and illustrations here on the left side about things that have to do with technology and somehow things that would be automated, and AI is definitely that ultimate form of automation where a computer would be performing tasks normally associated with human related tasks. Now, in day to day, we may be donating um, a lot about data into some of these systems that are smart, that are making decisions. A very uh, good illustration has to do with recommendation systems. Uh, I don't know about all y'all, but I know personally I have subscriptions to Netflix and to Hulu. My wife has a subscription to Spotify. And these are examples of services where there are libraries of content and you can watch movies, watch TV shows, series, listen to music. And part of the information that's collected is our preferences, whether we like something, enjoy something else. And then these systems would take that data to make recommendations in the future based on what we have already explored or played music or videos or otherwise. So kind of a very important point here is that artificial intelligence, these sophisticated forms of automation are going to be very, very efficient about finding patterns in data. In particular, when the volumes of data are scenarios where these volumes are so large that they would be the challenge of handling those volumes would be a little overwhelming for humans. So that's one instance in which it really is worth deploying the computers to do tasks that would be, where the computers could be very, very efficient. So finding patterns and scales or volumes of data that are really, really substantial, that's one thing that these artificial intelligence systems are really good at. And when we say data, just to kind of underscore, we mean data is information that is recorded in some fashion. So here are some illustrations. A fingerprint can maybe consider data. The photo of a portrait photo. Of course, you would argue that there are a lot of data points, but a photo on its own, that is considered data, a measurement, an observation. The age of an individual, that can also be considered data. So these are all examples. And this is kind of to underscore that when we are considering AI, artificial intelligence, data is really like the fuel or the lifeblood. It is not possible to have AI without data. That's the main point. So, um, and again, just kind of like underscoring this a little farther to illustrate this with um, something perhaps that we use on a day-to-day or know about or are within some proximity, an application like TikTok. Um, this could be something where there are videos. So the data in that context are the videos that are posted there, the videos that a user like myself, the videos I watch, how long I watch these videos for. So that's that pertinent data. The AI algorithms of TikTok would take that input data and then it would process, digest, ingest that data, and then would outcome some decisions. For example, what videos TikTok would line up on my page or my feed. Okay, so um, Another illustration of AI systems and input data can be Snapshot. That's another application. And here is a quick list of things. Snapshot would use information such as the date of birth of the user, the type of device, the smartphone, whether it's an iPhone 15 versus an iPhone, I don't know, 7 or something like that. Some information about how often a user is messaging their connections inside this application, and perhaps how often when they launch Snapchat, how often are they connected for. So this type of data would go into the AI algorithms of Snapchat, and then presumably something would come out, some decisions would be made, some predictions would be made. So when you're considering this type of setup, one thing that statisticians and mathematicians would say is what we have this statement here. There is input data. Something happens with the input data is processed. The AI machinery would do its magic, and then there is some kind of output. So the phrase here is garbage in, garbage out, right? So there is a notion of something coming in, some type of input, and if the quality of the data that is the input data, if that quality is compromised, then those decisions that are made or the predictions that are made, they would also reflect the quality. So that's there is actually a branch of artificial intelligence that's called responsible AI, excuse me. And responsible AI precisely deals with kind of mitigating the biases or preferences or areas that could potentially lead to erroneous predictions or predictions that are not really, they're somehow compromised. Okay, so I think this is a good point to switch over. A couple of things we would like to make observation. I need to end this show right here. I'm still sharing my second screen, but now we would like to switch this over. There are two things we're going to address. One that has to do with when using models or algorithms in AI, there's a notion of performance of those models. And then the other thing has to do with splitting data. So data is the blood life of AI. Without data, there is no AI. So we like to say a few things about how to split data when these algorithms are used. So I'm gonna stop sharing my screen, and Andrew is going to share his screen.
All righty. Thank you, Dr. C. All right, so today, I know this title's kind of maybe intimidating to you, but for this article, I'm simply going to focus on the artificial intelligence side and say quantifying for model performance of an artificial intelligence algorithm. Okay, so here we're talking a little bit about, not really about linear regression, like I said, but more about model performance. But linear regression is a topic that I teach to both my Algebra 1 and Algebra 2 students, and its roots, as you can see, are very mathematical. Like I said, I'm going to stay away from the math side, just looking at model performance. So you can see on the graph on the right, we have the price of houses compared to the size of houses in square feet. Well, on this graph, the dots represent actual data points, so what Dr. C was talking about earlier, recorded or observed information, right? And so this line here, this represents the average price of a house, the average of all these dots or actual houses in this data set. So as you can see here, this line is what an AI algorithm would use to make a prediction on a price. But as you can clearly identify the problem is that, I guess, predicting the price of a house wouldn't make sense to use the average, because what you're doing is you're saying that a house that's only 100 square feet is the same price as a house that's 700 square feet. Doesn't make sense, right? And as you can see here, we've got these little bars right here. And what this is a way to modify or quantify the model performance. And the problem is, if we just use the average, we're severely overpricing houses that are smaller and underpricing houses that are larger, right? So this really doesn't make sense. So what you do is, in artificial intelligence, to improve your model, part of what you do is you add an extra parameter. So as you can see here, whenever we add another parameter or we factor in the size of the house for the actual prediction of the house or prediction of the price, we get a much better model. We get more accurate. We get a more accurate prediction. So that's one of the things that people that create these AI, they try and do. They try and have better model performance by quantifying, finding ways to quantify the error and make that as small as possible. Makes sense. So like I said, this stuff is very mathematical, but that is the basic idea behind it. So what I'm going to do now is I'm going to post this link in the chat, and I'll give you all a couple of minutes to play around with this. This is kind of interactive. You can scroll and see how this changes when we add an extra parameter. And we'll take a couple of minutes to let you all play around with that, and then I'll hand it back over to Dr. Cintron. Let's see here. All right, so I went ahead and posted the link in the chat. Oh, you posted it too, I see. So if you missed it the first time, there's the second one. So take a couple of minutes and I'll turn it back over to Dr. Cintron. Go ahead and stop sharing. All right, I've got time for 2 minutes. So if you want to go ahead and take it away with the second article.
Okay, so we're gonna do something very similar. I understand if you feel we're going a little fast. It's this part is mostly about kind of exploring that interactive tool, and there are more and more technical details in that tool than is the scope of today's workshop. But just to give you some idea, at the end we're going to give a handout where you can go and revisit and, a little at a slower pace. So what Andrew briefed you about was the performance of models. So models in AI, they take in data and they do something with the data, and usually is about statisticians would say about estimating parameters and then using the estimated parameters to make predictions. At the end of the day, is about making predictions or making decisions based on the data. So the key idea was performance of the model. So just the data may not have good quality, then the model is going to perform in a certain way, and there is a way, a metric of measuring that. So the other aspect that's involved with this type of methodology is how do you actually how would the model use the data? So I'm going to do kind of what Andrew did. I'm going to debrief you about some key ideas and then give you a couple of minutes for you to basically scroll down. Sometimes this application is a little sensitive even to what type of browser you're using. I'm using Google Chrome, but sometimes if you scroll down, so this is a context that is motivated by a scenario of identifying the model. Ultimately the AI model would like to make a prediction about what type of data. There are two possible species here. The species are pets, and they are either dogs or cats or dogs. Um, and so there are two main so-called features that are present in this data set. For each data point, there is weight and there is fluffiness. And based on that, the goal of the model is to come up with what data points are in what side, whether they're cats or dogs. So there are three main things that are conveyed here. Um, we're only gonna say a few things about the two of those three things that has to do with the training subset and the testing subset. So you may ignore the thing about validation. But so the main idea is how the data will be utilized by the model. Excuse me. So imagine that you have some kind of bucket, I like to say a bucket of data, and you're ready to go and input this data into the model. The idea is that you don't input all the data at once. You take this bucket and maybe pour it into two additional buckets. One of them is going to be called the training data set or training bucket, and the other one will be called the testing. So when you are dividing or segmenting the available data, a very important thing to keep in mind is that this segmentation should be about basically creating a subset or a snapshot of the original data set in a way in which that subset preserves some of the general patterns of the data, so that bucket of that smaller data set is still a representative sample of the original data. So the training data will be used to pass on to the model for letting the model do what it does. The model is going to do its magic. And then some portion of the data, the testing data, will be withheld. The idea would be that then using the testing data to eventually pass on to the model, pass on data points to the model that the model has not seen before, and then assess the performance of the model. So this is illustrated here. Let's scroll down. Here's the training data. And this is a scenario in which there are two features here, weight and fluffiness. You could use one of those features at a time. And what you're seeing with my cursor here in the upper right corner is that if I click weight, then the data points kind of align in a certain way. There is a bar that appears. If I go with fluffiness, I'm using one at a time. So the data points kind of align in a certain way. You can see that there is a dog. I'm kind of grabbing that data point, and I can actually put that on the side where I think that's kind of the side where there's more dogs. Or I could also choose to use both. So we're gonna give some time for you to explore this web page. When you make it to this point, just make sure you play around with weight, fluffiness, and both of these features. The important thing is that there is this bar that appears, and when that bar appears, the data points are kind of segmented. The bar is basically a frontier or a boundary that divides the data points into two sectors. Okay. And so that's what training the model is about. And then the testing of the model would be using points the model hasn't seen before for purposes of evaluating the performance of the model. Okay, so training data and testing data, they serve the purpose of kind of this is how the AI models operate and work. So I'm going to give you the URL here. And we're going to take 2 minutes for you to explore this. Okay, so I'm going to put this in the chat. Um, and just scroll down the page and we'll continue in 2 minutes. Okay. Okay, so we are we're going to move on to another segment now. So we have kind of introduced the basic ideas of AI, artificial intelligence, and now we'd like to say a few more things about one of the subdomains or one of the branches of AI, which is called generative AI. So I'm going to share, I'm still sharing my second screen, but now I'm going to go on this um, slideshow mode. So and I think this perhaps would be, um, no, I'll do that on the next segment. But so generative AI will be a subdomain of artificial intelligence. It's actually a really big umbrella. And I'll tell you a little more about some of the subsets or subdomains of AI. But just to give you an idea what generative AI is about, just think about some of these technologies perhaps that are operated by voice commands where we're almost like having we're having a conversation, but a conversation maybe with your smartphone. This would be something. um, Amazon has something called Alexa. Apple has something called Siri. These are conversational AIs. And in that regard, the AI technology, part of it will take that as input, but part of the input has to be something, an action, a so-called prompt or command. So the model, the technology, the AI will take this prompt and it will then follow the command. And so the idea of generating something, it's about making or creating, and that's what the response of these systems is about. So commonly, this could be about creating images. So the AI would generate an image based on the prompt. Here is an illustration. In very simple terms, that prompt could just simply be the word astronaut. And with astronaut, then there would be some image of an astronaut. But here there are more specifications about the angle, about the gender of the astronaut, about, so this was generated, and I think this was generated with an AI called DALL-E. Okay. Then um, these type of tools may also generate text. And here is this is an illustration that's generating text, not just sentences in paragraphs, but in fact, text of a conversation. So the prompt includes details about the conversation between what individuals, and you can see the output there with the name of each individual involved in the conversation, the punctuation of column, and then whatever that individual is saying or contributing to this conversation. This is completely artificial in terms of this was generated by a program, that the text, the conversation. And here is another illustration of generative AI, where the prompt is not commands in terms of either voice or text, but the prompt is in fact an image. The output is also an image, but in this image, that is the prompt here, there is a part of the image that is color coded as to kind of indicating the model, remove this. This is something that could be used for filtering images, for cleaning images, for creating other versions of images, right? So this is an application of I don't know. So I'll tell you in a minute where all those things come from. Okay, so are there any comments or questions so far? Okay, so we had mentioned in the first segment of the workshop some of the basics of AI, sophisticated form of automation, um, taking input data to make decisions, make predictions. I think this would be a good time to kind of share some terminology here. So we have been using the acronym AI, the initial sort of abbreviation, right? So this stands for artificial intelligence. Okay, so this is something that now I don't know how to spell. So AI. It's very common to see the acronym ML. This stands for machine learning. So machine learning is a subfield of artificial intelligence. You will find also the abbreviation DL. This stands for deep learning. Okay. And one way, excuse me, perhaps one way of having a mental picture of these three things, how they kind of interact with each other, is thinking of AI as the big space, the big umbrella here. Um, and then inside of that universe of artificial intelligence, there is a subdomain that we call machine learning, ML. And then inside ML, you may think of the deep learning being a subfield, super specialized, that this is a representation with Venn diagrams, with this nested one set inside the other set inside the other set. This is one way of thinking of these three subfields. It's not exactly accurate, but this is, if we use this way to remember, that's fair game. Deep learning is a specialized subfield of machine learning, which is a specialized subdomain of artificial intelligence. I say it's not quite accurate because it's not exactly mutually exclusive like that, but it's more about having overlap. So, but if this is something that serves to paint a picture, that's so be it, right? So then we have another abbreviation, NLP. This is going to be abbreviating natural language processing. Okay, so a lot of what we do with text is about involving when you're doing a search in Google and you're just typing, a word or a phrase or sentences or a paragraph in Google. That action of search engine, that is natural language processing. Natural language understanding, which is part of what's involved when we talk to the systems like Siri or Alexa, that is involved or related to natural language processing. There's another field of computer science called computer vision. And as you can tell by the name, computer vision is basically a simulation of how vision works, but all digital and using algorithms. And then there's, of course, the acronym that we're discussing today, the G of GAI stands for Generative Artificial Intelligence, right? So these are um, some of the common acronyms, and yeah, just to keep that in mind. So machine learning is a subfield of artificial intelligence. What we discussed before would be probably this idea of making decisions or making predictions that would fall under models of AI that discriminate or discriminative discriminative models. They would learn from training data and they would make those decisions or predictions as far as this is a common task. Given the image, then is this classify this into a class or a group or category, right? That's a very common task. So an illustration of this is you pass the input image and you're asking the algorithm, is this a puppy or is this a bagel or an umbrella or what is this? And then the AI would classify, say, that is a puppy, that is a little dog over there. So this would be part of discriminative AI. But if we are dealing with generative AI, that's where the models use the commands, the prompts to actually create or make or generate something. So here we would be specifying that we want a photograph or an image of an animal, a puppy, a young dog, and then the AI says, you got it, and executes and produces this image. So there is still training, some of this framework of discriminative AI is still involved here. There is an underlying structure here where some of that machinery from AI or machine learning is still involved. But the main distinction is that generative AI is going to use models to create text or images or audio or videos to create some type of output. So we saw before an illustration of the prompt being an image of an astronaut with some specifications. Here you can see that that is expanded to have some type of font. This resembles now some text in the image. This resembles now the cover of a magazine. So it is a matter of using the AI tools that are best suited for maybe some tasks, whether it is to make predictions like the weather, maybe to make recommendations, as we were mentioning earlier, recommendation systems, or to categorize or classify a photo of a puppy or a bagel, or if we're using generative AI to write text or to write computer programs to write actual code, or perhaps to draw pictures, or something of that on that regard. Excuse me. Okay, so I think this is kind of the last segment we have before. Um, sorry, I have some notes here. And this also, this would be where I want to say something. Here's another acronym that is pertinent in this conversation. And this acronym, let's see, this acronym is GPT. You probably have seen this. So the G in this abbreviation stands for generative, okay? The P, it's something that stands for pre-train, as in training data. And then the letter T here denotes, and this is kind of an interesting word, transformer. Okay, so and that definitely sounds I don't know. I am from that generation that had the so-called Transformers. There were cartoons, and then there were, actual toys and stuff like that. So this kind of sounds like that in the sense of being robotics or something technological. And but Transformers are formally in this context are an architecture. That's the formal name, and they have revolutionized the generative AI. I mean, generative AI did exist before 2022, but the and transformers were invented around 2017, at least in the way we know them today. But let me just say a few things about what we're seeing here. This is a summary. The numbers that are displayed on the far right are units of months. And what's being reported here is the amount of time in units of months that it took one of these technologies. You see that at the top, there is ChatGPT, TikTok, Instagram, and then you go down the list. And so what's being reported is the amount of time that it took these apps to hit a volume of adopters of a volume of 100 million users per month. Okay. So the unit of time here is months. 12 months is a year. Three years would be 36 months. If you're looking at Instagram over there, Instagram is I guess 2 years is 24, 3 years is 36. Instagram is right in the middle. So it's 2.5 years, basically, 30 months. And you see something like Spotify. Spotify is appearing with 55 months. So that's almost like 5 years. And so something like Uber, which maybe a lot of you relate, an app that for transportation, ride share type of app, that is reported here as 70 months. I mean, this is almost like 6 years in reaching 100 million users per month. So when you look at the so-called Chat GPT, this is reported here to have taken 2 months. 2 months, that's 60 days for that technology to develop this critical mass of 100 million users per month. That is, to me, that's mind blowing and overwhelming. How come that happens that fast? Especially when you have things like Instagram and Spotify and things that are super, super popular. And the kind of that amount of time it took to develop that critical mass. Of course, this is a combination of things, perhaps. What are those underlying factors? Well, this has to do with the power of computers, specifically power of not every computer, but computers over the internet, virtual computers, the so-called cloud computing. This has to do with cloud computing architectures and so on. The availability of data sets, the design. So I mentioned that the word transformer is that definitely has to do with the design. And we're almost in the last slide here of this segment. I just wanted to mention this because one of the things that makes transformers stand out, a lot of the tasks, a lot of the computations that are now carried out by transformers were carried out by another type of architecture, another type of computer thingy that is called neural networks, artificial neural networks, which on its own is also very fascinating. It is named neural networks because it's a way of directly mimicking some of the functionality of the neurons in the human brain. So it's kind of like a simulation of how the human brain functions. And there is a lot of things that neural networks are useful and still today, but neural networks are sequential in nature, meaning that imagine there is a sequence of computations, and one computation has to be carried out and completed. And once that is completed, the next computation, the output of that computation is passed on as an input. So there is like a chain of computations, each of them linked to each other, and each of them has to wait for the previous one to be completed so that they can begin, start, and complete. So that's the idea of being sequential. With transformers, computations that are highly complex and elaborate can be performed not in sequential fashion, but simultaneously. Some of these computations could be fragmented, and there are pieces that can be carried out simultaneously or in parallel. And that ability makes the computations much more efficiently fast. And that's one thing where transformers have had the breakthrough, that adding that speed of computation. But one of the other things that makes them quite interesting is illustrated here. If you consider a phrase, a sentence really, that you read here on the very left side of the screen, the animal didn't cross the street because it was too tired. And the punctuation here is included as if we were part of the another character, were part of this set of words. So transformers are the type of architecture that can be used to analyze text and to actually come up with context of within this text. So within the same set of words, if we are referring to the word it, what you see there illustrated is a few candidate words that could be the words that it is referring to or is substituting in that phrase. And there is also a color code with some lines that are a little heavier than other lines that appear a little lighter. So those lines that are heavier, those denote the higher likelihood that that is the word it refers to. So if you consider a phrase as a sentence almost identical, you only change the last word. So instead of saying tired, you use the word wide. The animal didn't cross the street because it was too wide. Now that word it is referring entirely to a very different other word. And it is almost the same sentence. So humans, we are very good at distinguishing this. This would be a trivial exercise for humans. What is the word it referring to? But coding this and making computers basically perform this type of action is quite a challenge. Transformers have been known to be very, very efficient at identifying that in very good likelihood, in all likelihood. Now, in this second scenario, that word it is referring to street and not animal, as in the previous case. So, that was kind of like an illustration at the end. GPT, generative pre-trained transformer. Transformer is the type of computer architecture that would be able to do these kind of things with text data. Um, Transformers are also good at kind of finding or establishing relationships between words, and they can generate responses that feel very natural and it's kind of scary how when you're having conversations with something like ChatGPT or Claude, it almost sounds too good to be true. Okay, so maybe I was going a little fast over there, but I'd like to ask you, maybe I can end the slideshow. Um, yeah, I don't need to keep these annotations. And I'd like to ask you if you have any questions or comments.
So can you go back to slide 17 for just a second? Yeah, so like a basic example of this and just like plain English would be, let's say my family went to watch a movie, right? And then after that, say then they went out to eat. So you're already just you don't even have to think about it. You associate they with family, right? So it's kind of cool what this AI is doing because it picks up pronouns and then it associates it with like family, like they with family, right? So in this case, family would be data, and then they, it's like, okay, now it recognizes that they were talking about the family. And then you'd say like maybe they went out to eat after the movie, like it was great, right? So then it might confuse a little bit. So was it the movie or was it the restaurant they went to and the food they ate? Maybe it was great, or maybe it was both, right? So sometimes there just might be some extra details you might have to put in there. That's what I wanted to add to that portion. That's just a simplification of the context clues that this GPT things use.
Yeah, exactly. And at the end of the day, the this goes back to statistics, or it's all math. It looks it's all computer, but it goes back to statistics because that representation of the making, given the context and what words are highlighted in darker color and what lines are a little thicker, that's all about probabilities. So the machinery here is basically taking input, these words as inputs, and is computing weights or probabilities, and it's coming up with, when it says the probability of raining is going to be such and such. So of course, sometimes you carry an umbrella, go outside, and it's all sunny all day, and there's no rain whatsoever. And sometimes it's completely the opposite. But here is that kind of forecasting and prediction is based on probabilities as to what are the most likely words that are providing some type of context. Okay, so I also wanted to share with you a couple of things. One thing is the copies of the slides that we use today. And now that we are um, at this stage, so let me copy and paste, not that, let me copy a URL onto the chat window. And in that URL, you are going to be able to see three documents, PDF copies of the slides, but one of the documents you will see, is a document that says handout. The name of that document is Handout Democratizing AI. It would be best if you download that handout document from that URL in GitHub, um, so so that you can open this PDF on your own device. And once you have this PDF, this standalone PDF, then you will see that there are links to each of these. There are 5 tiles here. So the slides we use today, the first set of slides came from AI EDU. AI EDU is, they produce materials that are licensed as Creative Commons. They are open educational resources, and they are truly available to educators of all levels. So it's very easy to sign up for AI EDU. And once it's not automatic, you have to wait for a few hours or so. When they give you access, then you're able to download all their materials are lesson plans, slide decks, worksheets, a lot of stuff. And then the other slides we were using today, they came from a platform that's called DataCamp. DataCamp is what I would call affordable. So there is open and affordable educational resources. For me, DataCamp is what I consider affordable. If you use it for personal use, you have to pay a subscription. They do have a program for educators. Is right now that program is only for secondary education and higher education. But that's where the second set of slides came from. We also explore, even though it was fast, we explored MLU Explain. There is nothing to sign up for. That's a website, and you can use it at will. There are some other things that we didn't go into a lot of detail today that are more like interactive sliders and things where you can change values and the display changes. I would say AI for All is very similar to AI EDU. You don't have to sign up in AI for All, specifically in this link. You can download lesson plans and slide decks and worksheets. It's all ready to go. And then ISTE, I am an ISTE certified educator, the International Society for Technology in Education. One of their initiatives is in artificial intelligence. They have a lot of materials posted that are also free. They have other things that you have to sign up and create an account login. But on this landing page, of the AI initiative under ISTE, you can find guidelines for projects that you can work, and they have the projects kind of targeted to specific grade levels, for elementary, for middle school, or for high school, and they are very, very well detailed with alignment with standards and expected length times, time length, and that kind of thing. So I just wanted to tell you where some of these materials we used today came from. Also, I want to remind you that this is part 1 of 2. So on Saturday, I'll be sending a reminder. We're going to have a follow-up of this workshop where we're actually going to use some specific tools like ChatGPT, where we're going to dive into how can we use ChatGPT, for example, to create question banks or create variations of questions or create like lesson plans and um, you know those kind of applications. Generating so this output of generative AI would like to see some of those tools kind of tied in to perhaps things that you're using in your classroom. So as we are kind of getting ready here towards the end, I'd like to share with you 2 things. One is that the Tennessee STEM Innovation Network is one of our sponsors, and so um, I have a questions here. So there are basically 2 exit surveys or exit tickets that would be great to hear from you. The first one that I'm pasting in the chat window right now is directly from the Tennessee STEM Innovation Network. There's a couple of things I know. Kembela is asking me something. I'll address it in just a minute. So if you could take 5 minutes or so to answer that first survey, it shouldn't take too long, but you may need, besides the URL, there's a portion where they ask about the STEM Innovation Hub. The hub at ETSU is called the Northeast STEM Innovation Hub, Johnson City. And then another thing they ask in that survey, the training session or topic, the name of this training session is Generative AI for K-12 educators. Okay, so let me go back to the question. Do you know if school districts have, I don't know. I don't know. That is a good point because sometimes there are, yeah, that's a good point. But to that point, am I still showing the screen? Yeah. So um, for the AI EDU, the educator downloads their materials. So you're downloading PowerPoint files and docx Word document files. Some of those, the worksheets, for example, you could use in digital form or you could print out, create hard copies. So you download the materials and then you use them in your classroom as you see fit. So AI EDU is not quite an LMS or something. You download the materials and you do whatever is suitable. It would be something similar for AI for all. That's Google, like Google Slides, Google Docs, but again, you download and then you create your own version. And the projects I was mentioning from ISTE is a similar thing. You download the project is a guideline and is a manual for educators, and you as an educator create whatever you would like out of that manual. So that would uh, be a way around this issue of restriction. The data camp, it's if you are in high school, data camp, that would be something that could be restricted because data camp is like a learning management system. It would be a website and you would add students and your students would log in. And so there could be a little issue with data camp there.
Yeah, I was gonna say, I think that I can't speak for all districts, but I know the school district I'm working in, I don't believe they have these AI apps blocked, but honestly, it just depends from district to district which ones have them blocked and which ones don't.
Thank you.
You're welcome. Did that answer your question?
Yes, and I'm a little worried because I think the students are using that for like regular class. So that's not really preparation for when they go further because they're cheating.
Oh yeah, I'm in the high school, so I know what you're talking about. I see, especially I hear it from a lot of English teachers and stuff are out there using these chat GPTs and
Yeah,
all these GPT top AI. They're using them to like write papers and different things like that. So I'd see the concern there.
yes. Thank you.
You're welcome.
And that is a good point. I'm gonna now copy the URL of the other survey that we have two survey tickets, I mean, two exit tickets. And the other one, I'm pasting right now. Um, in this other one, I'm sorry that I'm bombarding you, but it's just like these workshops are at ETSU. They are sponsored by the Center for STEM Education, the Center of Excellence for STEM Education, and one of the sponsors is the Tennessee STEM Innovation Network. But there's some more information that they usually collect from the attendees, like what school they are working or school district. But in this second survey that I'm pasting in the chat, we have some questions at the end there about the tools, generative AI tools that you are either currently using or you see that is worth exploring or, kind of diving in. And definitely those use cases that you see are controversial, that you're saying, well, this is kind of removing the part where the individuals was learning or thinking, So those are kind of the things that we would like on part two of this series. Would like to have some forum to kind of exchange ideas about what uses and misuses maybe of what's currently going on.
And I think that's where I can provide more information, especially where in a high school classroom. I can see the right and wrong ways to use AI, the ways that can be used as a helpful tool, and also the ways that you can abuse it.
Yeah, Ariel, I would say there are positive side and negative side of everything. So if you see positive side, there are more positive side to generative AI than negative side. So this will be, as this is the future, let's progress further and take the negative side in the second phase of this program. Over to
Yeah,
you.
yeah, definitely, yeah. Any more questions or comments? If you are here still with us, I truly appreciate you joining us. I think you could save the chat. Um, you go to the chat, there's an option, there are three dots there, and you can save the chat, and maybe that's one way of taking with you both of these URLs for the exit survey. Um, and definitely the second survey that has some questions about how you're using Gen AI or tools that, hey, I'm curious. Well, we mentioned ChatGPT. There is going to be some demo of ChatGPT, but maybe there are tools that you are curious and you haven't had a chance to explore it yourself. So we'd like to hear from you in that survey because we'll use that to make sure we have a use case or an application on Saturday. And what did I say? ChatGPT. There's another one very similar called Claude. Microsoft, if you have subscription to Microsoft, for example, at ETSU, we have subscription to Microsoft 365 and OneDrive. And through that subscription, Microsoft has a generative AI called Copilot, Microsoft Copilot. So when you have a subscription to Microsoft, sometimes on the institutional level, you have access to Copilot. So we can, depending on what we hear from you, we can have a demo of Copilot. And there is another platform called School AI that we may also have a demo on Saturday. And there is another one that's a tutoring, like a smart tutor or conversational chat in the form of a tutor, which is aligned with some content and some specific standards. We may also have a demo, but definitely it will be better if we hear from you in the exit survey. Thank you, Carrie and Lisa and Kembla. And I welcome your comments and questions you may have at this time.
Yeah, so if you know if anyone else who's involved with education, the part two of this workshop will definitely be more tool oriented, like the different tools that you can use as an educator regarding AI. So if you know any other educators that are interested in this kind of stuff, make sure that you reach out to them and make sure that they come Saturday, because we're going to be showcasing a lot of helpful tools for educators on Saturday.
So Terry is chiming in here about something that happened in English, in an AP English class. And I think what Terry is mentioning is back then, the issue was not a smart writer writing the documents for the students. The issue was potentially the parents or some other human doing the writing for the students. And then this teacher, this AP English teacher, found a way to mitigate that by having individuals in under supervision writing. So where there was no um, there was a way of like monitoring that they were really producing or generating what they were supposed to without additional help. So, yeah.
Yeah, unfortunately, that's the best way around it, is just make sure that you're monitoring your students as they're working. Or what I like to do in my class is students don't have their phones while they're working.
Yeah, which is very challenging. So I attended a workshop at ETSU for professors, and the workshop was about how to set up some type of policy in a syllabus for generative AI within the context of a class. So I'm professor of mathematics. There's some from chemistry, some professors from English, and especially the people that were teaching like composition and English literature, but um, this thing where you write about character fiction, like teaching fiction. Um, that was a challenge because these tools are language, that's what they're called, language model. We mentioned natural language processing. Well, one subdomain of that is language models, especially large language models. And they would write stories with specific characters and it would be tricky if somebody is using those tools to write essays or write stories or novels even. So one of the attendees in that workshop, she mentioned that the methodology was doing something similar to what Terry and Andrew are mentioning. She would early on the semester have the students write not an essay, but in fact like a paragraph, but it would have to be written by hand in in front of her. So she would collect these samples of handwritten paragraphs. And she was giving them the prompts, write a paragraph about so and so, something, I don't know, Declaration of Independence or something specific like that. And then they would have to do so. She would collect these samples and would archive them. And then eventually throughout the semester, she could then cross-reference the sample of the handwritten paragraph against the essay that person was submitting. And then she could find patterns about to determine, is this essay artificial or is this essay, does it have like kind of some type of, it was like a forensic approach, find some kind of forensics or fingerprint or DNA type to kind of establish like, is this human generated or is it generated by some kind of synthetic computer or something?
There's also tools that are like, I guess, partially computer generated, which I think helps improve your writing, right? Like Grammarly. Grammarly is something that I used when I was an undergraduate writing papers. I would use that too. I guess I would use that as a tool to help me proofread the papers that I've written, right? It would pick up on grammatical errors and help improve my writing tone and different things like that, which is a useful tool.
Yeah, I think that that is also interesting where we are kind of the state, right? Because it's a matter of like, do we embrace or adopt some of these tools? And if we adopt them, how? What type of parameters? I think having an assistant, having a tool like that to help us polish or improve, that could be useful, but it matters how we set up. One of the things I learned in that workshop was to have attribution, to use attribution, which it means if you allow your students to use some kind of tool like that, you need to establish a culture where they disclose, I'm using ChatGPT or I'm using this other thing, I'm using Grammarly, and this is how I'm using it. So it's disclosing that they're using that technology, how they're using it, and also establishing a culture of if there are mistakes, that technology makes mistakes, that you are the intellectual owner, you own the mistakes of the computer and yourself. So it kind of is a way of like keeping people accountable.
Yeah, I wanted to say more about that on Saturday too with the GPT and classroom resource or the classroom based AI that creates material for you as a teacher, having that expertise in your field to be able to go through and review what the AI is generating, to go through and review that and make sure that's quality and you can edit it. I guess the bigger picture is the AI does a lot of the heavy lifting, and then you, as the expert, go through and review what it's generating for you, and you can tweak it and make sure that it's the way you want it to be.
You can filter it, right? And you can really use it as a what is it called? An Iron Man? The computer, the Iron Man
Jarvis.
Jarvis. You can use it as Jarvis, or Knight Rider was the car.
Yeah,
Kit was like
yeah,
always really sassy and stuff. So very good. So thank you, everybody. Again, Terry, Rajesh, Andrew, it was an honor and a pleasure to have you attend, and hopefully you can fill out the exit survey. And we would love to host you again on Saturday. And I look forward to hearing from you. Thank you again.
yeah. Thank you, everyone.